now that we have installed PostgreSQL, it's time to tune the default parameters a bit, because Postgres is installed with very conservative parameters that allow it to work almost on every system, but are not necessarily tuned for a specific workload. Since we are concentrating on analysis, then we will tune for read performance mainly, and the absolutely most significant tuning you can do is use an SSD. It's just much better than any rotational disks. Then you could reduce the max connections parameter. By default it's 100 or so, but if you reduce it to 10 or another significantly lower number, then you can spare some memory. Then you should adjust the buffer cache. For read workloads or analysis workloads, it's recommended to use 1/4 or 1/2 of the available RAM on your machine. So on this machine with 8 GB, that would be 2 GB, starting with 25%, but you can ramp it up to 40 or 50% of available RAM. Then you should increase the temp buffers. This is how much memory PostgreSQL will use when doing temporary operations like materializing intermediate results or something. If you go above that threshold, then it will use the disks, and this will be much slower. But be aware, this is a per connection setting. So on a machine with many connections, every connection can use up to this amount of memory, so be careful. But if you're working with a small workgroup or alone, then you can ramp this up pretty high. The same is for workmem. Workmem is if Postgres has to do some ordering or something else to work on the data, sorting it, then it will use up to this amount of memory for doing this, and above this it will go to disk. The maintenance workmem is mainly for vacuum jobs, so for the garbage collection of PostgreSQL. If you ramp this up, then it will do the vacuums in the background much faster. Then the next two parameters, they are relative and have no dimension, so it's a relative cost. Sequential page cost says how expensive it is for the system to do a full table scan or do a table scan, so reading blocks sequentially from disk. And the random page cost says how much or how expensive it is to do random access to the disks. The default parameters is 1 and 4, but this is for mainly for rotational disks, where it's much more expensive to do random reads. If you have SSDs, then you can lower the random page cost. Some people even set it to the same as sequential page cost. And this means that the optimizer will favor index scans over sequential scans. Then we have the effective cache size. Here you have to see how big is your available file system cache when PostgreSQL and all the other stuff you have on the system is running. So how much of the memory is left for caching the file system. And then you can enter this value here. This is just a hint for PostgreSQL so that it knows how much data will be cached in the file system cache of the operating system. And the last one is a bit obscure. This is mostly for Windows. This is by default on. If you set this to off, then it will almost double your throughput on Windows doing writes on the disks. Apparently what this does is a very expensive operation on Windows. So you can see the corresponding entry in the PostgreSQL message archive where people found out that you better set this to off on Windows. And that's pretty much it, though. That's all you have to change in your PostgreSQL conf to to tune your Postgres instance for read speed. And this is what we will do now. So now we will change these parameters in the actual PostgreSQL conf and see what happens. So this is going to be vi PostgreSQL conf. And you see PostgreSQL conf has a lot of parameters, but actually you just have to change those that I showed you recently to tune it for improved read performance. So here we have the max connections parameter. We will set it to 10. And next one is the shared buffers, which is here. So we'll set this to 2 gigabytes. And we have the temp buffers. We will set this to 256. And here we have the work mem. Set this to 256 also. And the maintenance work mem will be also 256. And now we have to find the page costs. So here we have the page costs, and since we are on SSDs, I'll put this to 1.5. And the effective cache size, we can leave this at 4 gigabyte. And the update process title, it's here, but we can leave this to on since we're on Linux, so we don't have to change this. Okay, now let's see if it still works. Yes, it looks like it worked. Yeah, that's pretty much it. This is all the basic tuning you have to do for optimizing your personal PostgreSQL for read or analysis performance. Thank you, and we see us in the next installment of the series.